Okay, this is problem 10 on the college algebra uh, practice final review. Um, and problem 10 is another power function. So that's kind of why it's fit in here with the kind of log and the other exponential problems. But this is a little different. It's also asking about graphing. So this is your chance to graph an exponential function. And it says list the parent function. So make sure you read and do these little things. And list the transformations. Then we're going to graph it. So there's really three things you got to look for here. And when I do the rubric, those are three things that are going to be on the rubric. Did they list the parent function? Did they list the transformations? And then go look at your graph. So make sure you get all three of those things. The parent function, remember the parent function is just essentially the simplified version of this without the transformation. So you might not be able to get the parent function if you can't take away the transformations. So let's go ahead and look at the transformations. First transformation we're doing is that we're subtracting 3 before we're raising 2 to this power. And since that happens before, that minus 3 is a right shift. Okay, so we're going to go right 3. It's a right shift 3. And then finally we've got this minus 5, and that's after we've done the power. After we've raised 2 to whatever number, then we do that subtraction of 5. So that happens after the fact, so that makes that a down 5. Those are the two transformations. So we just take those things away, and the parent function is just f of x equals 2 to the x. Okay? So here's what I would do if I was graphing this, if I was taking the test, and I wanted to do well, wanted to pass the class and all that kind of fancy stuff. I would go ahead and just graph this parent function. F is 2 to the x. And then I would just go ahead and shift it. Okay, so anything, so I would just start putting numbers in for x. And I'd start with 0. 2 to the 0 power is 1. Right, so when x is 0, my function is a 1. If I put a 1 in, 2 to the first power is 2, so 1 gets me a 2. If I put a 2 in, at 2, 2 to the second power is 4. So now I'm at 4. And we'll just do one more. We'll go 3. 2 to the third power is 8. So 5, 6, 7, 8. And anything that's negative, of course, is, like let's say I do negative 2. That's going to be 1 over 2 to the positive 2, or 1/4. So at negative 2, I'm already at a 1/4. And so this thing is our classic exponential curve. It looks very flat along here, hardly moves at all. And then does this. Now, you've plotted all these points. And we don't have to recalculate any of these points for this function. Right, this 2 to the x minus 3 minus 5, because all we have to do is apply the transformation to each one of these points. We just need to go right 3 and down 5. So let's start with this one right here. We'll go 1, 2, 3, 1, 2, 3, 4, 5. Okay, let's do this one. 1, 2, 3, 1, 2, 3, 4, and 5. Do this one. 1, 2, 3, 1, 2, 3, 4, and 5. 1, 2, 3, 1, 2, 3, 4, and 5. 1, 2, 3. Okay. So now I've got all this. It's all shifted, and all I have to do then is just draw in. And I didn't have to do these calculations. I didn't have to make a t-table. Okay, didn't have to do any of that at all. It's all right there. And that is absolutely the easiest way to take care of that problem. Um, Again, you wouldn't have had to. You could just go ahead, not graph the parent function, just start putting values in for x and calculating their value. And there's absolutely nothing wrong with doing that. Um, but so do your own thing. But this is what I would do, and that's problem 10.